In this video, I'm going to review how to express numbers in scientific notation, engineering notation, and using SI prefixes. So let's get started. Here are a few numbers written in scientific notation. I'm sure you've seen this before. What makes this scientific notation is that I have one non-zero digit in front of the decimal point and then some other digits. And they're always times 10 to some whole number power. In this case, times 10 to the fourth. 10 to the fourth is really 10,000. And if you multiply something by 10,000, of course, you really just move the decimal point over 4 places to the right. So I could write out the longhand version of this number. And my decimal point started here. And if I multiply again by 10,000, it's really moving the decimal point 4 places over. So the longhand version of writing out this number in scientific notation is 50,230. And of course, let's do the second example. Again, this scientific notation, I have one digit in front of the decimal point. If I multiply times 10 to some negative power, now I move the decimal point the other direction. So my decimal point starts here and I'm going to move it 5 places over. So let's see. It starts here, 1, 2, 3, 4, 5. My decimal point is now here. So this is the long version of my scientific notation number here. And let's just do one more. This last one, again, I have one digit in front of the decimal point and then times 10 to some whole number power. I'm going to move the decimal point 3 places over to the left. And so my new number, right, my decimal point started here, 1, 2, 3. This is the longhand version of this number written in scientific notation. All right, let's do a few other examples going the other way, where I'm giving you a number written in longhand and I want to express it in scientific notation. So the decimal point is really here and I want it to end up right there with just one digit in front of the decimal point. So I know how I want to end up, 2.3654. And of course, in scientific notation, it's going to be times 10 to the something or other. Well, it's going to be fourth, right? If I multiply times 10 to the fourth, I'm going to move the decimal point 4 places over, and I'm going to get back what I started with. So that is my number in scientific notation. Let's do one more. Here I have to move the decimal point the other direction. Right now I have to move it 1, 2, 3, 4, 5, 6, 7 in order to get 3.25 times 10 to the negative 7, right? If I multiply times 10 to the negative 7, I'm going to move it 7 places in this direction and I will get back my original number. So hopefully that makes sense. These are two numbers that I have now expressed in scientific notation. Now let's look at engineering notation. Engineering notation is really very similar to scientific notation. There's just a couple of differences. And one of the differences is that the exponent must be a multiple of 3. In other words, 3 must go into this exponent evenly, like 3, 6, 9, 12, and so forth. And the other thing is, instead of just having one number in front of the decimal point, you're allowed to have either 1, 2, or 3 digits in front of the decimal point. So must be a multiple of 3 for the exponent, and you can have either 1, 2, or 3 numbers in front of the decimal point. So let's express these numbers written in engineering notation in longhand form. And it's really the same thing that you do in scientific notation. Times 10 to the 9th means I move the decimal point 9 places over. So 5, 7, I'm going to have to add one more 0. Remember, I'm starting there. So I move it 9 places. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and that is my number written in longhand. Again, I started right there and I moved it 9 places over. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is another number in engineering notation. Again, you're allowed to have either 1, 2, or 3 digits in front of the decimal point, and I'm multiplying by 10 to the third, so it's 6.213. I got to move it 3 places over. 1, 2, 3. That is my new number, or rather that is a number written in longhand form from my engineering notation number. And times 10 to the negative 6, you know how that works. You just have to move it in the other direction. I'm starting there and I have to move it 6 places over. 1, 2, 3, 4, 5, 6. So my decimal point ends up there, right? I started here, 1, 2, 3, 4, 5, 6. And that is my number written in longhand form. All right, let's go the other direction. So here are a couple of examples where I'm going the other way. I'm giving you some big numbers here, and I want you to write them or express them using engineering notation. So my decimal point is really starting right here, and since my 10 must be to some power that's a multiple of 3, that means I have to move the decimal point in groups of 3. So if I'm starting here, I've got to move it over 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, 5 groups of 3. Remember, I have to end up with either 1, 2, or 3 digits in front of the decimal point. So I have moved my decimal point 3, 6, 9, 10, 11, 12, 13, 14, 15. So my number expressed in engineering notation is 23.7 times 10 to the 15th. Again, if I multiply this by 10 to the 15th, I will move the decimal point 15 places over, and I end up with the long number that I started with. All right, let's do one more going the other direction. Again, you have to move the decimal point by 3. So it's starting here. That's one jump of 3. That's another jump of 3. Now, if I did another jump of 3, I would end up with too many numbers in front of the decimal point. So I'm just jumping over 3, 6 places. So I have 5.64 times 10 to the negative 6, right? If I multiply by negative 6, I'll 1, 2, 3, 4, 5, 6. I'll end up with what I started with. That's all there is to it. Now let's write some numbers using SI prefixes. SI is just the metric system, really. It stands for System International. And I'm sure you've seen these prefixes before: giga and mega, kilo, unit. I mean, there's really no prefix there. Milli, micro, nano, pico. I'm sure you've seen these things or heard of them before, and you don't have to memorize this. These are all in your digital electronics reference table. And notice that I'm only writing down the ones that go with engineering notation. These are I'm only writing down the ones that are 10 to some multiple of 3, right? 9, 6, 3. I'm going by jumps of 3 here. So let's express this number. This is 3,500, and this funny symbol is ohms. It's a unit of resistance. Don't worry about that now. Let's express this using SI notation. Well, it's really a two-step process. First, I'm going to express this using engineering notation. So that would be 3.5 times 10 to the third, right? If I multiply by 10 to the third, I'm moving this point 3 places over. I'll get back what I started with, and times 10 to the third. Well, what is that in using an SI prefix? 10 to the third is kilo. So this number using SI notation is 3.5 kilo. And the units is that funny symbol there. That's ohms. Again, don't worry too much about that. All right, let's take a look at the next one. So I want to express this number in SI notation. And again, I'm just going to keep moving the decimal point until I get 1, 2, or 3 numbers in front of the decimal point. That's 1 jump, 2 jumps. I'm going to end up with 125.8. Oops, 0.8. I don't know why that does that sometimes. So if I move it over, let's see, 1, 2, 3, 4, 5, 6 times 10 to the negative 6. Oops, negative 6. Negative 6 is micro. So I have to write 125.8 micro. That's what 10 to the 6 means. And the units is volts, so microvolts. So again, writing things using an SI prefix is pretty easy. You just have to first write it in engineering notation, and then you just look up in your reference table what the appropriate SI prefix is and stick that right in there. All right, this is the very last slide. We're almost done. So you might be asked to convert between different SI prefixes, and this is really very simple as well. Again, I've written all my SI prefixes on top here, and I'm going to convert megavolts, in this case 0.00058 megavolts, to millivolts. So I'm starting here at megavolts, and I want to go all the way to millivolts. Well, that's a lot of jumps there. That's 1, 2, 3 jumps, and every time I move to the right by a jump, I'm really moving by 3 decimal points. That makes sense. In other words, a megavolt or a mega, yeah, in this case it's megavolts, is 1,000 kilovolts. A kilovolt is 1,000 unit or 1,000 volts, and a volt is 1,000 millivolts. So every time I move over to the right, I'm really moving the decimal point a jump of 3. So let me just say this again. I'm jumping 3, 1, 2, 3 jumps to the right, and every jump is a move of 3 decimal places. So I'm starting here. This is hang on. I'm gonna rewrite this. 1, 2, 3, 4. How many? 1, 2, 3, 4 zeros, and then 5, 8. So I'm starting here, and every time I jump over, I have to move my decimal point by a jump of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Have I jumped the right number of times? 1, 2, 3. 1, 2, 3. Oh, I went once too many. I don't need that last guy. All right. So I'm starting here and I'm jumping over 1, 2, 3. My decimal point ends up there. So my number is 58000. This is now millivolts. Millivolts. This should make some sense to you, right? A megavolt is huge. So a megavolt, a tiny amount of megavolts, is 58,000 millivolts. I know this is a little weird, a little tricky, but I think this should make some sense. Okay, so I just converted megavolts to millivolts. Now I'm going to do one where I'm going the other direction. I'm starting with nanovolts. I'm starting right here, and I'm supposed to go... starting with nano ohms, that's a unit of resistance, and I'm going to kilo ohms. So I'm starting at nano and I'm jumping over to kilo. That's 1 jump, 2 jumps, 3 jumps, 4 jumps to get to kilo. And every time I jump, I move the decimal point 3 places over, and I'm going, notice I'm going in the same direction. When I jump to the left, I'm moving the decimal points to the left. When I jump to the right, I move the decimal point to the right. So anyway, my decimal point is starting here, and I'm supposed to move it now this way. Let me just copy this number over. 54300. My decimal point starting there, and I'm supposed to jump over 4 jumps. 1, 2, 3, 4. And every time I jump, that's a jump of 3. 1, 2, 3. Of course, I'm going to need a whole bunch more zeros. 0, 0, 0. Starting there, 1 jump, 2 jumps, 3 jumps, 4 jumps, and my number is, I really don't need those zeros at the end, my number is 0.000000543, and that's in now kilo ohms. And when you're done, it should make sense. A nano ohm is really tiny, so a whole lot of nano ohms is really equal to a teeny, teeny, teeny amount of kilo ohms. I know these are a little tricky, but you have a few to practice, and you should practice them and check your answers, make sure you got it right. And that is it.